All right, let's solve this question here. Find the values of x for which x minus 2 over x minus 4 is less than or equal to 3. To do that, we're going to need to graph it. And in order to graph it, I need to make sure that I've got my asymptotes and my intercepts. Let's find the asymptotes first. I'll do that in this little section over here. So we've got y equals, we're going to find the asymptotes of this graph here. The x one's the easiest one to find. It's just when the denominator is equal to 0. So it will be when that part there, x minus 4 is equal to 0, which means it's going to be x is equal to 4. 4 minus 4 is 0, that's what it can't be. Our y asymptote, our horizontal one, like we talked about, we're going to divide each term by the highest power of x, which in this particular situation is just x. Now, the reason we do this is to look at what happens as each individual part of my expression that I have here as it approaches infinity and negative infinity. As x here approaches a really large number, 2 divided by a massive number is just going to be tiny. It's going to essentially be 0. So while my x's over x will cancel to be 1, these are going to be cancelled entirely. So the expression can also be written as 1 minus 0 over 1 minus 0, which is just 1. And that's going to give me my horizontal asymptote. And I've drawn them both down here below already. There they are, my asymptotes there. Now that I've done my asymptotes, let's find my intercepts. We can find the y-intercept by letting x be equal to 0, which is a nice easy one generally most of the time. There we go. 2 over 4, which is going to end up being a half. And then we've got our x-intercept, which is when we let y equal 0. So we've got 0 is equal to x minus 2 over x minus 4. Solve, multiply both sides by x minus 4. 0 times anything is 0. And we have x is equal to 2 as our intercept. X is 2, y is a half. I'll plot them already right here. Now that we've got this, let's do our graph. Do it in black. So our curve is going to, let's do it in bright green. Yeah, there's going to be my curve there. That's what it's going to end up looking like. Going through the intercepts, and then we have the other part of the curve all the way on that side over there. But this part is where we end up reaching the second bit. That part there is not too bad. What we want to do here is utilizing this graph, we want to find the values where this curve is less than or equal to 3. And when we're looking at something that's less than or equal to 3, we need to consider what values are above and below the values that we're going to be looking at. So let's take a look at it right here. This is our value for 3. I'll do it in red. Let's take 3 here. If we look at my graph here, we want to find out the values where, if that is our value here, where my curve is going to be less than or equal to 3. A y value of 3, I should say. Where is it? Where are you? Right here. So when does my curve have a y value that is going to be less than 3? Well, if we take another look at this side over there, forget about that vertical line, we see that essentially that's going to be that point there. Anything on the left-hand side of my asymptote is below the y value of 3. Anything. Let's just rub out this red line here. Getting your horizontal and verticals confused can be not ideal sometimes. So we want to find out when this equation has a y value that's below 3. And it's essentially going to be anything below the red line that I've put into place there. Anything's going to be below this line there. And you can see that's essentially going to be most of the curve. There's only going to be a small point, that is here, where the curve does not have a y value that's less than or equal to 3. So essentially we need to work out what that coordinate is, what that value is going to be. So let's actually solve for that value. So if we solve, 3 is equal to x minus 2 over x minus 4. Let's find out what that value is there of that curve when I sub it in, what that x coordinate is. Solve. Multiply both sides by x minus 4. Expand. Collect like terms. add 12 to both sides, and it's going to end up being, we have that value as x ends up being 5, which means that, so x minus 2 over x minus 4 is less than or equal to 3 when x is less than 4. It can't be equal to 4, it's going to be less than 4 because it can't actually be a value of 4 that we have here. And when x is greater than or equal to 5, that's when that curve is less than 3. When the y values end up giving a value that is less than 3. It's just that point there that I circled initially where this isn't true. And that's how that works.